So thanks, everyone. It is very much my pleasure to be here today to talk you through some examples of typical assessments that you might do at the early stages of forest project due diligence. So we're going to jump straight into classification here. Now, this is a land classification of Cambodia. Now, we've chosen Cambodia because we've been able to draw around some, if I just make that transparent, we can see I've got 5 project areas here that I've drawn around some areas that we know are REDD+ projects. Some are actual ones, some are potential ones. And this is just to make the story a little bit more realistic today. The key ones here that we might keep revisiting, the Southern Cardamom is the very large one at the bottom. So a lot of the numbers that will come out for forest carbon will be bigger than the rest. This little orange one in the middle is the possible project that we will consider as well. There's another one, I could just list the projects here. Tumring, the blue one, is one that some of you may have heard of recently in the last couple of years in terms of some of the reports about REDD+ projects. Now, if any of you have got some Earth observation experience, and I'm sure with the numbers that we have today, some of you do have that experience, you can go and customize your own classification. The interface on Earth Blox gives you plenty of opportunities to calculate and to do supervised or unsupervised classification, depending what information you've got, just with dragging and dropping a few blocks. But what I've done here is taken a shortcut, one of many shortcuts that we can use in Earth Blox to speed up your processing, make things easy and quick, by using an existing land classification. And this is based on satellite data, Sentinel-2 data from the last few months. And this is the WRI Google land classification, so the dynamic world classification, where they've used deep learning methods to be able to do weekly classifications at 10-meter pixel sizes. If you want to find out more, it's written up in their Nature paper from 2022. Now, the cloud cover can mean that you don't get data every week, but you can be sure that you're going to get the most up-to-date data because they're processing it in every pass from Sentinel-2. Now, you'll notice that one of the things in these blocks is that these blocks are fully customizable. So if you wanted to change the colors for some standard way in which you present land classification, there's opportunities to do that. And it's also worth noting that the dynamic world taxonomy for the classes aligns very closely to the land use classes presented in the IPCC Good Practice Guidance. And that makes it much easier then to use it for estimating carbon stocks and greenhouse gas emissions. So the first thing we're going to look at here is investigating current conditions. So we need to know what's happening now with our project areas and the surrounding areas. And that helps us understand the current drivers and the pressures on these forest areas within our projects. Now, the classification helps here because that gives us information on the on crops and forest cover, tree cover. But we've also got a selection of base maps that we can use. So if you need to look and investigate the terrain of some of these projects, we've got terrain information. And we've also got the NICFI base map. So the NICFI base map is from Planet. It's processed monthly. So what we have is the base map is the most recent processed month. And it has 5-meter pixels. So as you zoom in, you'll see that that gives you quite a lot of clarity in terms of what the key drivers are around the forest projects that you're interested in. So you can see down to the level of individual fields and what may be happening there. And that helps us understand the local pressures on the forest. Now, we've chosen to look at the whole country here. So the examples that we're going to look at today are for the whole of Cambodia, and that's to emphasize the scalability of Earth Blox. So Earth Blox has access to lots of global data sets so that we can do this anywhere. So although I'm doing an example in Cambodia, we can do this anywhere in the world. We're looking at whole country analysis because we know that it's important for you when you're investigating issues such as leakage, or when you're trying to establish baselines for reference areas that you want to be able to look across a national or certainly a larger area so that you can see everything that is happening even outside of your project areas. So that's why we're looking at the whole of Cambodia. And just as an aside, if you're interested in monitoring of projects that are already established, then do come and talk to us afterwards. We're not going to show some workflows for doing that today, but we can talk through how you would use Earth Blox to do the monitoring if you're interested in that. And also notice that today I'm going to be using a total of 9 different data sources, and that includes climate data as well as satellite data. And normally we know that the collection of such data can be very time consuming, can be very complicated, and you might need to visit multiple different websites in order to access all that information and bring it and download it to your desktop and everything. And that's one of the key things about Earth Blox, is that it has all this data to hand, plus many more. So we have 31 data sets available just now, and that's increasing every week. And if you have a special data set, that it might be a commercial data set, for example, that you've got a license to use, then come and talk to us so we can make that available within Earth Blox for your use only. Now you see here on the left, the way everything that you've seen on the map here is being generated by these blocks on the left. And this is just a combination of our blocks. This is how the Earth Blox works. There's something that tells you what data to bring in, where to do the analysis, what time period, how to collect that data together, how to display it on the map. You'll notice I've also got a couple of table blocks here because I'm also interested in the quantitative values, not just the maps, but also looking at statistics such as, in this case, these are their 5 project areas. And this is how large each of those areas are in terms of hectares. So our proposed project area, for example, is 34,668 hectares. The Tumring project is 68,268, and we can see a breakdown in terms of our classes here. So of that 68,000 hectares, 47,923 hectares are trees, 9,562 are grass, etc. And we can also use that to look back in time, because this particular classification and data goes back to 2015. So not quite the 10 years that some of you will need, but very close to that. So the next step is, well, what do we do in terms of looking into the past? Because this is the current conditions. So it's really important to know each of our project areas, proportion of forest, how big the areas are, and to get an idea of what the pressures are on these projects so that we know what a suitable intervention would be. But we also need to look in the past. So I'm going to jump to a different tab here. And on this tab, we're going to look at the history of the landscape. So the whole of Cambodia, but in particular, we're interested in our project areas. So we're interested in questions such as, what are the baseline trajectories for land cover and forest biomass? Was this forest 10 years ago? Has it been used for anything else? And this block on the left, I'm just going to get this running because it will take a few seconds. That's not surprising because it's 20 years of data that it's now looking at 25-meter pixel resolution, and it's calculating forest biomass across the whole of Cambodia, so 18 million hectares or so. So let me use that this time to explain a little bit about the blocks over here. This is one of our template workflows. So we're building these workflows just for you so that you can access them, and all you need to do is refine some of these parameters, such as the area that you're interested in or the time period. And you just click the run button, and it will do it for wherever in the world that you're looking at. You can upload your own shapefiles and things on the map interface. And we're building a number of these template workflows to make it easy for you to do a number of these tasks. So all of the things that I'm showing today will be available as template workflows that you can use. Now on the left here, we've got a number of things. I mentioned the toolbox here where you get all the details to build your own blocks, because you don't have to just use our templates, you can build your own ones. It's also worth noting here that one of the key things about Earth Blox is that everything is visible. So all the component parts of the workflow here are entirely transparent. And we're aware that visibility and transparency of your methodology is important to a lot of people. It's an important part of setting up a project so that you're able to disclose your methods. You're able to open up the steps that you went through if you want to be audited in terms of your methodology. And it's also fully customizable. So the key block in terms of the calculation of forest biomass here. So I'm going to get rid of the tree cover in the background. So this is our forest biomass map across Cambodia. The key calculation here is in this yellow block. This is their calculator block, and it calculates the forest biomass from the satellite radar data that we're using, and it uses an algorithm that is in a peer-reviewed journal article. It was published in PLOS One, so it's been calibrated and verified. The methodology is in the public domain. And that's where we have this emphasis on using published, verified methods that have gone through peer review, and we're simply making it easy for you to apply them to your specific task. And you can even edit that equation yourself, should you wish. It's as easy as using an Excel equation. Now, we haven't shown them for clarity, but we're also providing pre-built calculator blocks for different parts of the world based on published peer-reviewed articles. And that means that you can just pick and choose which one that you want to use, or the one that you think is most appropriate. And it's also important to realize if you've got your own data, so if you have LiDAR data or field data, then do come and speak to us, because we can help you generate your own relationship, and you can incorporate that into your own calculator block. And you can keep that as your proprietary information. That's not for us to share, but you can just customize it for your own application and data. In terms of support, just in passing, when I mention support, there is the button in the bottom left here, our help center. We've got quite an extensive help center to make sure that there's lots of support to help you using Earth Blox and these templates. And also we have the experts on hand. So Geneviève and Stephen mentioned that already. And across Sam and Geneviève and Mike, myself, and a number of others, I think it's something quite crazy, like over 100 years worth of experience in using satellite data for mapping forests. And we are on hand here to make sure that you can find the right solutions using Earth Blox. So do come and speak to us. Now, another thing to note is in terms of exporting. So we know that you need to evidence your analysis and reports and presentations. So I won't identify every point on the way as we go along, but there is opportunities. All the data that we show, you can export as PNG files, you can export them as animated GIFs. The tabulated data you can export as CSV files. So everything is transportable into other tools if you need to, or to add to presentations. It's also possible for Earth Blox to export GeoTIFFs. So if you need to do some other kind of analysis offline, that's something else that you can do. Now, what I'm plotting on this map here is the biomass density. So it's in megagrams or tons per hectare. And what we are interested in, it covers the time period, just to note, from 2007 to 2020. And what we're going to do is look at the actual quantified data for our 5 projects. So we've got our 5 projects here, are in different colors in these graphs. And so this graph, this and the tabulated data, this is showing the mean biomass density, so the tons per hectare over time for our 5 projects. Now, you note that 2019, there's a missing data there, and that's just because the satellite coverage missed a piece of Cambodia during 2019. So that's the source data, not from Earth Blox. Now, we can see that 3 of these projects are fairly consistent over time. These graphs, by the way, are interactive, so we can kind of switch those off to focus on these 2. So the Tumring in our proposed project area, you can see quite a steady decline here. Now, the fact that you can see this change in biomass density over time, it's dropping in this graph, but in our reforestation project area, you can imagine that you can also detect change with increasing biomass as well. Now, the biomass per unit area is something that we're interested in, but of course, many of us are interested in the total carbon content as well. So this graph is actually showing the total amount of carbon over time. So Southern Cardamom, if you remember, was the very large project in the south. That's much larger than all the other projects, so that's why it's got upward of 60 million tons of hectare. So we'll get rid of that just so we can see the other trends just now. These other 2 projects are fairly consistent. The gap in the 2019, of course, but the general trends look very stable. But what we can see here is that our proposed project area and the Tumring area have this steady decline in the carbon content. So it starts off at 8 million, and then 13 years later, it's down to a little over 2 million, almost just about 2.5 million tons of carbon. So this kind of data is important for us understanding what the baseline loss is and the rate of loss to determine which of these projects or project areas has the most potential to be an actual project. Now, we also want to look at where this is happening. So I'm going to move this workflow out of the way. I'm going to use this workflow. And what this workflow is going to do is it's looking at the years from 2001 to 2021, and it's going to display the time at which the deforestation happened. So the legend here shows that from a pale yellow all the way up to the dark reds represents the time of the deforestation. Now, because of the way it scales these smaller pixels, the pixel sizes here are 30 meters, so they're quite small. So there is extensive loss during this period across the area, but you'll see that there is a level of detail that you get down to the individual pixels, where you can see individual fields even being deforested. This is important in terms of our assessing what the land cover has done over the last 10 years. In fact, there's this block that I disabled. So this block is now going to just filter out. So we're only going to look at the last 10 years. If we look at the last 20 years, our proposed project site has had a loss of 11,258 hectares of, so it's almost a third of the proposed project area has been lost over the last 20 years. Now that I filter this, then what we're going to see is that only looking at the last 10 years. So one of the key things that we're interested in is what has happened in the last 10 years. So if we look at our dashboard, it's now only 7,000. So it was 7,000, which is 3/4 essentially of that area that was lost over the last 20 years. 3/4 of it has actually been lost in the last 10 years. So we can get the quantitative data, and we can also map that. And just finally, I'm going to return to our biomass map. So one of the things that we've looked at in terms of that carbon density is comparing it to other data sets. So we've got another data set that has used JEDI data and Sentinel-2 to combine to confirm that our trends in forest biomass are what we might expect. The background image here is also the tree cover from 2000. So we have a baseline map for the year 2000, letting us know what the conditions were in that date. And you can see that we can generate animations of the forest loss over time. And should you wish to do that for social media and the like, you can export that as an animated GIF. So far we've looked at the current conditions, and we've looked at the historical trends, extracting things like the size of the project areas and the rates of loss of forest area and forest carbon in the projects. We can see across the entire country of Cambodia what the trends are. But the last thing I'm going to look at here are the non-permanence risks. So I'm going to look at 4 different risks here. And we know that some standards like the VCS expect a risk assessment, and we've also spoken to some of you about this. And it's clear that all too often is that this risk assessment happens quite late down the road after setting up a project, and sometimes it maybe should be done a bit earlier. So I'm going to show you some example templates that we've got to check some of these risks based on the historical occurrence. So this first map is the wind risk. So what this scale is showing you from 0 to 19, this is the number of months over the last 20 years that have had higher winds than a threshold that has been set. So you can set your own threshold as to what you consider to be high winds. And this is identifying all those areas that have had the highest winds over that period of time. Now you'll notice that along the coast, not surprisingly, that's where most of the high winds are occurring. Typically storms coming in from the across the coast. But actually from our project area point of view, in terms of evaluating the project, southern cardamom might be at risk a little bit down the southern edge there because it's near the coast, but the other projects are not anywhere near areas that are prone to high wind. Our next one is the fire occurrence. So the deep red colors here represent a higher frequency or higher intensity of fires. This goes back 7 years, and that's only for simplicity because it starts to get look much more messy if you go back more than 7 years in this case, but you could go back 20 years. So there's 20 years worth of data in terms of the historical fire occurrence. And we can see that the Southern Cardamom project, much less impact from fire over the last 7 years. Tumring, the blue one here, has a particularly high rate of fires. And you can do a simple index to represent some kind of score. So in our score here, where we've summed the brightness temperatures, it's the highest number that comes out here is for Tumring, as you might expect. So there's a way to quantify how you might rate the risk for each of our projects. The next risk factor is flood risk. So which areas are prone to flooding? So this is taking data from the last 40 years. And what it's showing is the dark blue areas are areas of permanent water. The light blue areas are seasonal water. So seasonal flooding essentially, and most of that is around the river, as you might imagine. And so we can quickly see from this data that in fact none of the 5 projects are at risk from seasonal flooding. And this last one is drought risk. So this map shows the number of years out of the last 40 years. So it's taking 40 years worth of annual rainfall measurements. And then it is setting a threshold of 75% of the normal annual rainfall. If it drops below that, it's categorized as a drought year. Now, again, on the blocks on the left, you can see there's a simple little equation here, which is just the threshold, less than 75. And it's very easy to edit that. And so if in other areas of the world, it might not be 75% that you want to use. So it's easy to set the threshold. And what this map is showing you, though, is the number of years out of that 40-year period that have been classed as a drought year. So in actual fact, the maximum is 3. So even the very deepest red here has only had 3 drought years out of the last 40. But if this is important to you in terms of the amount of rainfall, again, you can see that you could rate the 5 individual projects, and Tumring again is in an area probably more prone to variations in rainfall than the other 4. Right, so that wraps up my demonstration for today. I hope you found that useful.